Welcome dear students. So today we are beginning with the second part of your integration using parts. Okay, so here today we will deal with two very important kind of integrals. So the first one is this one, okay, and the second we have got the two formula out here. Now talking about their proof, I'll just prove this part, you will prove this by yourself. Okay, so formula number 1 I'll prove, 2 you will prove by yourself. Okay, now in order to arrive at this particular integral, let me take this integration. See here carefully. I'm taking here integral e to the power x fx. Okay, now as you clearly see that there is f dash here. Now you know that out of f1 and f2 in the product, you know that you differentiate f1, isn't it, and you integrate f2. Yes, okay, so basically I'm going to consider e to the power x as f2 and fx as f1 because you have f dash, that is you have differentiated f here. Okay, so in that case we get, see here carefully, so this is my f1x, so f1x will remain as it is. We need to integrate e to the power x dx minus integral of d by dx of what? Fx, right? So fx, fine. Now integral of e to the power x dx into dx. Okay, now you know that how much is this? This is just e to the power x, isn't it? So this is e to the power x fx minus, now how much is this? This is f dash of x, isn't it? So this becomes, this is e to the power x again, so this becomes e to the power x f dash of x dx, right? Now let me take this to the left hand side. So if I do that, then I'll get e to the power x fx dx, I'm sorry, dx is also there, dx, this comes over here, becomes plus e to the power x f dash of x dx is equal to e to the power x fx. Okay, now if you see here carefully, can I write this left hand side as e to the power x fx plus f dash of x dx? Is this allowed for the left hand side? Yes, so we have this is equals to e to the power x fx. Now see here carefully, we got a new formula. The formula says that this integral will be equals to this much. So your formula is e to the power x fx. Okay, so whenever you have got this kind of form, then your answer will turn out to be this much. That's all you need to remember from the first part. Now from second part, you have got two formula. You may pause the video and note down the formula, and after this I'll prove the first formula for you. So you may pause the video and note it down. Okay, so let's prove this. So we have integral of e to the power ax cos bx dx. Okay, now this falls, okay, let me write down the rule for you. So the rule says ILATEC, isn't it? Okay, now here you see that e to the power ax, that is this one, is of the form which e, right? So this is my e and this is my trigonometric function, that is t. So my first function is this one, okay, and the second function is this one. Okay, so that means I need to integrate the second function, isn't it? And we need to differentiate the first function, that is this has to be differentiated and this will be integrated. So in that way we have cos bx integral of e to the power ax dx minus, so differentiation, that is dy dx of cos bx integral of e to the power ax dx, close the bracket, and you have this. Okay, fine. Now integral of e to the power ax is e to the power ax by a, so we have cos bx, isn't it, minus, now the differentiation of cos bx will be minus b cos bx. Okay, See, the differentiation of cos will be minus, so it becomes plus. Okay, so it is cos bx, I'm sorry, sine bx. In fact, this is sine bx. But as per your chain rule, we need to differentiate bx also. So what is the differentiation of bx? It is just b. So that b will be kept front, or if you want to keep it outside, that also can be done. Now what is the integral of e to the power ax dx? This is already done. This is this much, isn't it? So that's why this a can be kept outside. So we have e to the power ax into sine bx, and we have got dx also. Okay, now let's simplify this further. So we see that there is again integration by parts in the second integral, that is this integral, isn't it? So let's apply integration by parts here. So we have e to the power, okay, let me write it as 1 by a e to the power ax cos bx plus b by a. Now again, this falls under your exponential category, this falls under your trigonometric category. Then obviously this has to be differentiated here. So in that case, this becomes sine bx integral of e to the power ax dx minus integration. Now d by dx of, now we need to differentiate sine bx. So it is sine bx integral of e to the power ax dx, and we have got one more dx outside. Okay, so close the bracket. Okay, so this is 1 by a e to the power ax cos bx plus b by a. Okay, by the way, let me call this to be I. Okay, so this is my I. So this is my e to the power ax by a. So this is again sine bx minus. Now differentiation of sine bx will be as per the rule. It is sine bx. For sine bx, differentiation will be cos bx, and again due to chain rule we need to differentiate bx also. Now the differentiation of bx will be just b, and that will be kept outside. Now what is the integration of e to the power ax? It is exactly this much, so that's why this a is also kept outside, and you have integration, I'm sorry, not integration, it is e to the power ax here. Okay, and we have got this dx also. So close the bracket. Now see here carefully, I is equal to this much, isn't it? Now is this equal to I? Yes. So that's why we have 1 by a e to the power ax cos bx plus b by a. Okay, so 1 by a e to the power ax sine bx minus b by a, and this whole integral is integral I. Okay, and what is our aim? Our aim is to calculate the value of I, isn't it? So let's open up the bracket. So we get 1 by a e to the power ax cos bx plus this is b by a square e to the power ax sine bx minus, plus into minus is minus, so this is b square a square I, isn't it? Now we'll take this to the left hand side. So in the left hand side we already have I, so this comes over here, becomes plus, so b square a square I. So we have now 1 by a e to the power ax cos bx plus b by a square e to the power ax sine bx. Okay, now let's simplify this way here. Now the I is common here, isn't it? So if I is common, so this can be written as 1 plus b square by a square in the left hand side. So in the right hand side you see that a square is the LCM. Okay, and you can, okay, so first let's simplify. So if a square is the LCM, divide this LCM by a, you'll get exactly a. So a into this whole thing becomes a e to the power ax cos bx plus, now what is this? This is b. Okay, so divide this a square by a square, you'll get 1. So 1 into this entire thing becomes b e to the power ax sine bx, isn't it? Okay, so let's simplify here. Now this can be written as I into a square plus b square by a square, isn't it? Yes. So this is equal to, so here you see that e to the power ax is common. So if I do that, then we get here a cos bx plus b sine bx divided by, you have a square, isn't it? And a square gets vanished. So from here you see that I turns out to be only I. So we have already e to the power ax into, so we have a cos bx plus b sine bx. Now this a square plus b square goes to the denominator. Okay, now check whether this is the same. Yes, so that's how we solve, or we prove the formula here. In the same way you are going to prove the other formula as well. So you may pause the video and note it down. Okay, so let's start with the first question for the day. So we have the first question here. Now before we do this, let me write down the formula. See, the formula is actually belonging to this form: e to the power x fx plus f dash of x dx, and your formula says that this integral will turn it to be this much, isn't it? Okay, now e to the power x into sum or difference, let me call it sum or difference, because plus and minus both are actually same, but in some other property they are different. Okay, now this into this is there, right? So please remember, this kind of question you will get in your objective. Okay, so here it is e to the power x into sum or difference of some functions here. Okay, so if one is fx, other one has to be fx. Okay, same thing is happening here. See, there's e to the power x and there's a sum of two different functions. Now if we are able to identify whether one is fx and other one is f dash of x, then we are done. For example, if I take this to be my f, if cos x is f, then what is f dash? F dash is minus sign. But do we have minus sign here? No. So that means this cannot be taken as fx. Remember. Now let me take this to be fx. Now if this is my fx, if this is my f, then f dash will be, that is differentiation of sin x, will be cos x. So is this cos x? Yes. So this becomes my f dash. So as per the formula, this has to be equal to e to the power x fx. So e to the power x, and what is fx? Fx is sin x. So it is sin x plus c. See how simple is my work? So this kind of question you will see in your objective. Now let's go back to this. Now can I call this as this form? No, because we have only one thing here, that is sin x plus pi by 4. Okay, fine. Now we know the formula for sin a plus b, isn't it? So this can be written as e to the power x sin, okay, so let me put this bracket. So this is sin a plus b, sin a cos b plus cos a sin b, isn't it? So this is the formula. Now you know what is the value of sin cos pi by 4? So it is, let me write sin x first. So cos pi by 4, that is cos 45 degrees, 1 by root 2 plus cos x into sin 45 is also 1 by root 2. So dx. So you can take out 1 by root 2 common. So 1 by root 2 is common and can be kept outside the integral sign. So you have e to the power x sin x plus cos x dx. Isn't it same question? So what is this? This is my f and this becomes my f dash. So your answer will be 1 by root 2 e to the power x, okay, sin x, isn't it? So sin x with constant of integration. So you may pause the video and note it down. Now let's observe this question. So here again you have e to the power x and sum of two different functions here. See, be patient, be calm. So choose one as f, okay, and differentiate that. That's all you need to do. For example, if I choose cot x as my fx, then the differentiation of cot x will be minus cos x square. Now do we have minus cos x square? No. So that's why this has to be fx, because, okay, so let me check here. Okay, so let me write, let fx is equal to log sin x. So let me do this way. Now this means that f dash of x will be, now for different log it will be 1 by sin x, and for sin x it will be cos x. So how much is this? This is cot x. See, we started with fx, that is this one, this one, and we got this to be f dash, isn't it? So that's why this can be written as, okay, so this can be written as, okay, so this can be written as integral e to the power x. Okay, so what is this? This is fx, isn't it? Fx plus, and what is this? This is equals to f dash of x dx, and as per the formula my answer will be e to the power x fx, isn't it? So with constant of integration, so what is e to the power x? Okay, what is fx? In fact, fx is log sine x, isn't it, with constant of integration. So this will be my answer for this particular question. Now let's observe this one. Now, is this a sum of two different functions? No, because there is a division sign out here. So our aim is to convert this into sum of two different functions. Then let's do this. So we have integral e to the power 2x. Okay, so let's put the values out here. Okay, you know that this 1 plus cos 2 theta is 2 cos square theta, and 1 plus cos 2 theta is 2 cos square theta. That is the half of this. So this becomes just 2 cos square x. And this can be written as, see here carefully, can I write this as sine square x plus cos square x instead of this one? Yes. Plus we have 2 sine x cos x instead of this sine 2x. Okay. And we have dx here. Okay, see here carefully. So we have this 1 by 2. Okay, so this 2 can be kept outside. So it becomes 1 by 2 integral 2 to the power e to the power 2x. Okay, so here can I write numerator as sine x plus cos x whole square? Yes, because this is a square plus b square plus 2ab, right? So this becomes a plus b whole square divided by this 2 is already outside. So we have cos square x here. So this is this much. Now half integral e to the power 2x is there. Now can I write this as sine x plus cos x by cos x whole square? Is this allowed? Yes, this is also allowed, because here also we have got square, here also we have square. Okay, so this is a half integral e to the power 2x. Okay, so this can be written as now sine x by cos x plus cos x by cos x, isn't it? So we have got whole square dx. So this is actually 1. Okay, so this can be written as, so let me do it this way. Okay, so this is equal to, so half integral e to the power 2x. Okay, so what is this? This is tan x, isn't it? So this is tan x plus 1 whole square dx. Yes. Now again, it's not of this form. We don't have a square out here, but we got square. So let's try to apply a plus b whole square formula. So this becomes e to the power 2x. So this becomes tan square x plus 1 square plus 2 tan x into 1, isn't it? So we have dx also. Now pay attention to this. What is this? So this is half integral e to the power 2x. So this is 1 plus tan square theta, which is sec square theta, isn't it? So we have 2 tan x here. Okay, dx. Now you might be you might have observed here one thing, that is, in the formula we have e to the power x, but here we have got e to the power 2x. So we have to remove this 2, isn't it? So for that we will do some substitution. So for that, let me take 2x is equals to t, or you might take, if you want to take theta, that is also fine. So from here you see that dx will be equals to half of d theta, isn't it, by differentiating. So if you call this to be integral I, so therefore I becomes, see here carefully. Okay, so from here x is how much? X is theta by 2, right? So this becomes half. Okay, so we have e to the power 2x is theta, so e to the power theta. So this becomes sec square x is theta by 2 plus 2 tan theta by 2 dx. Now instead of dx I have to write half d theta, so half can be kept outside and I'll write d theta here. Okay, now let's observe one thing here. So you see that differentiation of tan theta will be this much, but you cannot take only tan theta to be fx. The entire thing has to be taken fx. Why? Let's see. So let fx is equal to, I'm sorry, this is f theta, right? So f theta is equals to 2 tan theta by 2. You know why I have taken theta here? Because this quantity depends on theta, so that's why I have to write f theta here. Now let's differentiate and check. So we have f dash of theta will be equals to, so 2 is already there. Now for tan it is sec square theta by 2, and we have by chain rule the differentiation of theta by 2 will be 1 by 2. So 2 and 2 gets cancelled, so we get sec square theta by 2, which is this one, isn't it? So that's why your I can be written as, so 1 by 4 integral e to the power theta. Okay, now what is sec square theta by 2? It is f dash of theta, isn't it? Plus what is 2 tan theta by 2? It is f theta. Yes. Okay, now as per the formula this has to be equals to 1 by 4 e to the power theta. Okay, as per the formula we have e to the power x fx, that is f theta here, with constant of integration. Now let's put the value. So this is 1 by 4 e to the power theta is e to the power 2x f theta. Now what is f theta? It is 2 tan theta by 2, that is 2x by 2 with constant of integration. So this and this gets cancelled, so this and this also gets cancelled, so your final answer for this will be equal to, okay, so final answer will be, so how much is this? Half e to the power 2x, this is just tan x, isn't it, with constant of integration. So you may pause the video and note it down. Okay, now let's observe this question. Now whenever you see this kind of question, what you need to do is first you need to just work with this. Okay, so what you do here is, okay, let me directly do here only. So we get e to the power x. Now this can be written as x plus 1, because we have got plus 1, we'll write plus 1. If you have plus 1 you have to write plus 1, if you have got plus 2 then you have to write plus 2. Okay, now in order to make this much I have to put minus 2, isn't it? So we have x plus 1 whole cube dx out here. Okay, so the first step is clear to you, isn't it? So we have e to the power x. Now you know that we have to write as something plus something, so this can be done in this way. See here carefully. So this can be written as x plus 1 by x plus 1 whole cube minus 2 by x plus 1 whole cube, isn't it? So we have dx. Now see, this is one term, this is another term. Okay, so here we see that this is e to the power x. Okay, so this is 1 by x plus 1 whole square. Yes, plus, now this can be written as minus 2 x plus 1 whole cube dx. Okay, now what am I going to do is I'm going to consider this to be fx. Why, you will understand. See here, so we have fx equals to 1 by x plus 1 whole square, which in turn can be written as x plus 1 to the power minus 2, right? So from here differentiate, so you get f dash of x equals to, for power it becomes minus 2 x plus 1 minus 2 minus 1. Okay, into, as per the chain rule we need to differentiate the inner part also. This becomes 1 and the differentiation of 1 is 0. Now how much is this? So this turns out to be exactly minus 2 by x plus 1 whole cube, isn't it? Now is this equal to f dash? Yes, so that's why, therefore if you call this to be I, so therefore your I will be equals to integral e to the power x. Now what is this? This is fx, isn't it? So fx plus this is your f dash of x. So this becomes your f dash of x, and the formula says that this is equal to e to the power x fx with constant of integration, that is e to the power x. And what is fx? Fx is 1 by x plus 1 whole square. Yes, so we'll put a constant of integration, and if you want to put this e to the power x in the numerator, that also can be done. So you may pause the video and note it down. Now let's observe this question. So for that, here you have got whole square, isn't it? So let's expand this. So if I call this as I, then this becomes, okay, so let me do this way. Okay, so this can be written as e to the power x. So if you apply a minus b whole square, this becomes a square plus b square minus 2ab. Okay, so this will be the expansion of the numerator, and the denominator is 1 plus x square whole square. Why am I keeping this? Because I have got 1 plus x square here. So we have got 1 plus x square here. So I'm trying to cancel them out. Okay, see, otherwise you could have put the formula for a plus b whole square here also, but I'm not doing that. You will understand why. Okay, so this is integral e to the power x. So this is 1 plus x square by 1 plus x square whole square minus, you have, okay, let me write it plus only. So we have minus 2x by 1 plus x square whole square dx, isn't it? So this and this gets cancelled, so only 1 by 1 plus x square is left. Now in this case, I am going to call this fx to be equal to this one, 1 by 1 plus x square, which in turn can be written as 1 plus x square to the power minus 1. Now let's differentiate this. Okay, so we get f dash of x equal to, see here carefully, for power it becomes minus 1 plus x square minus 1 minus 1. This is for power. Now as per chain rule, we need to differentiate the inner one also. So for 1 it becomes 0 plus, for x square it becomes 2x, isn't it? Now simplify this, this will be equals to minus 2x by 1 plus x square whole square. Please check it. So that means this is my f dash and this is my fx. So that's why your I can be written as, that is, this integral can be written as integral e to the power x. So the first part is your fx, second part is your f dash of x dx, and you know that this is equal to e to the power x fx with constant of integration. So your answer turns out to be e to the power x. What is fx? Fx is 1 by 1 plus x square, isn't it, with constant of integration. So this will be your answer for this particular question. Okay, similarly, if you see this problem, same thing will happen. So if you call this as your I, so this can be written as, so e to the power x, so x by x square plus, you can write this as minus 1 by x square dx. So this and this gets cancelled. So in fact this is e to the power x 1 by x plus minus 1 by x square. Now if I ask you what is your f and what is your f dash, you will definitely be able to tell me. So you say that fx is equal to this one, isn't it? No, your fx will be this one. So if this is your fx, then your f dash of x will turn out to be minus 1 by x square. Okay, so therefore your I, this integral can be written as integral e to the power x 1 by x is what? 1 by x is fx plus this quantity is how much? This is f dash of x dx. Now as per the formula, this integral is equal to e to the power x fx. Now put constant of integration, so e to the power x, and what is fx? Fx is 1 by x. So that's why your answer will be this much. So you may pause the video and note it down. Okay, so here we have got another question. So let me call this to be integral I. Now this seems to be like those two formula, you know, formula 1 and formula 2, which I had proven the first one, second one I asked you to prove by yourself. So basically this belongs to that category, but here we have got square. Okay, so let me write down that formula for you. So the formula that I proved is e to the power x, ax in fact, ax cos bx dx was equal to e to the power ax, a cos bx plus b sine bx whole divided by a square plus b square. So this was the formula. Okay, now in order to reduce this into this format, I'm going to make use of one more formula from your class 11 trigonometry. That is 2 cos square theta is equals to 1 plus cos 2 theta. Okay, so basically this 2 goes over there and becomes this much. So if I use this formula, then this becomes e to the power x into 1 plus cos 2 theta by 2. I'm sorry, not d theta, it is, I'm sorry, not x, not theta, it is just x. So we have dx. Okay, so this 1 by 2 can be kept outside. So we have integral e to the power x dx plus integral e to the power x cos 2x dx. Please check it, isn't it? Because this half is outside, so e to the power x into 1 is e to the power x dx. So this half is again outside only, so we have e to the power x cos 2x dx. Now, if this question comes in your exam, you cannot directly use this formula, okay? Because it's hard to memorize also, okay? So, you know the way I proved this? You have to do this also in the very same way. Okay, that means you will first take it out separately. Okay, we have, you will write we have, you will write, and you will evaluate e to the power x cos 2x dx in the same way as we proved this. Okay, so first find this, then you go back to this. That's how you have to do. But since we know the formula for now, we will use the formula. Okay, so this is half. Okay, so this is integral e to the power x dx, which is e to the power x, isn't it? Plus, so here if you compare this formula with this, tell me the value of a. The value of a is the coefficient of x here. So the coefficient of x here is 1. So that's why here you see that a is 1. Now tell me what is b. B is here equal to 2, isn't it? So the value of a is 1 and b is 2. So let me put the value in this formula. So you get e to the power ax, that is 1 into x, that is x. So a cos bx, that is 1 cos 2x, isn't it? So this is 1 cos 2x plus b is 2 sine bx, that is 2x by a square plus b square, that is 1 square plus 2 square with constant of integration. So half. Okay, so you can take out e to the power x also outside, so it becomes half e to the power x. So this becomes 1 plus, so this becomes cos 2x plus 2 sine 2x by 1 square plus 2 square is 5, right? So that's all is my answer for this particular question. Okay, so dear students, let me call this to be integral I. So here we have this part. Now here you have to again use this formula. See here carefully, this is cos a cos b is equal to, see here carefully, the formula is cos a plus b plus cos a minus b. So this is the formula. Okay, so consider the bigger number to be your a and this is your, the smaller one will be your b. So this is your cos a cos b, isn't it? So cos a cos b is half, so this half can be kept outside integral sign, e to the power x. So this becomes your cos a plus b, that is 3x plus 2x plus cos a minus b, that is 3x minus 2x, I'm sorry, 2x dx. Okay, so this is half integral e to the power x. Now this is cos 5x plus this is here cos x, isn't it, dx. Okay, now here what you can do is, now you know that if you take 1 to be f, you won't get f dash. So this will not fall under the first thing that we learnt today. So for that you have to write this as integral e to the power x cos 5x dx plus this will be written as e to the power x cos x dx. Now this falls under the second kind of formula, the formula which I used just in your question number 8. Okay, so let me write down the formula again for you. So you have integral e to the power a x cos bx dx was equals to e to the power ax a cos bx plus b sin bx by a square plus b square. So this was the formula. Now for the first one, for the first integral, that is this integral, it's going to be e to the power, okay, ax. So a is 1, yes, so e to the power x a cos bx, that is just cos 5x because b is my 5, plus 5 sin 5x by 1 square, that is a square, plus b square, that is 5 square, plus in the same way this also becomes e to the power x cos x plus sin x by 1 square plus 1 square. Please check it out with constant of integration. So this becomes half into e to the power x can be kept outside, so e to the power x, so this becomes cos 5x plus 5 sin 5x by, this is 25 plus 1 is 26, plus this is cos x plus sin x by 2, yes, with constant of integration. If you want to simplify this further, that's your choice. So this will be your answer for this particular question. So dear students, here we have got 2 more questions. In fact, this is going to be my last question for today. Now I'm just going to give you a hint out here. Okay, so the formula for this I'm going to use out here is this one. From logarithm I'm using this first formula. So you know that if a is equals to log b to the base c, then this is your logarithmic form. Now for this the exponential form will be, see here carefully, the exponential form will be b equals to c to the power a. Okay, okay, so if this is, see, this is your logarithmic form, this is your exponential form, that's what I'm using out here. So for this what am I going to do is, let me do some substitution out here. So let me write, let x is equals to, I'm sorry, x is written, so let me write theta here. So let theta is equals to log x. Now as you are doing calculus, you know that the base of log will always be e here. Okay, so if that is so, then from here what is x equals to? So let's see, compare this with this. So a is theta, okay, so b is my x, so that's why b, that is x, will be equals to c. C is the base, and what is base? Base is e here. Okay, and a is this number, that is theta here, isn't it? So we see that x is e to the power theta here. Okay, now let's differentiate this. So you get d theta is equals to 1 by x dx, because the differentiation of log x will be 1 by x, and for x it will be dx. That is, from here dx will turn out to be x d theta. And what is x? X is e to the power theta, so e to the power theta d theta. So therefore your integral I will change to, so instead of dx we have e theta d theta, isn't it? And we have sine, what is log x? Log x is theta. So that's why this whole integral will change into this. Now after this you will be able to do by yourself. Okay, now let's have another question, question number 11 in front of you. Okay, so this is your I. Okay, so here you clearly see that the substitution that we have to make here is tan inverse x is equals to theta. So in that case your x turns out to be tan theta. Okay, and the differentiation will give you dx by 1 plus x square is equal to d theta. So this integral I will change into, see here carefully, e to the power m tan inverse x is theta. So e to the power m theta. Okay. Now this can be written as 1 plus, see there are 2, right? So among this I'm taking, see we have got 2, isn't it? So x square 1 plus x square. Now I'm going to call this to be d theta. Alright. Okay, so 1 is left, that is 1 plus x square is left. And what is x? X is tan theta. So that's why I have to write tan square theta, and for the remaining one, that is dx by 1 plus x square, I'll write d theta. I hope this thing is clear to you. Okay, so we have e to the power m theta. So 1 plus tan square theta is sec square theta d theta. So this is e to the power m theta cos square theta d theta, isn't it? Now after this also you will be able to do by yourself. So we'll close with this. Thank you very much.